Let's discuss question number 21, right? Decomposition of 1 mole of CH3OH liquid occurs at high temperatures as follows. So methanol CH3OH liquid, it becomes what? Carbon monoxide gas and what? 2 hydrogen gas. The enthalpy change is what? Positive 128 kilojoules. When you consider 1 mole of what? CH3OH liquid, right? Which of the following is incorrect for the above reaction? First statement. The heat absorbed when 1 mole of CH3OH gas is decomposed is less than 120 kilojoules. Now listen, CH3OH liquid should be converted to what? CH3OH gas. Then CH3OH gas becomes what? Decomposed into CO gas and 2H2 gas. So they're asking the enthalpy change here. That means when you're making CH3OH gas into what? CO gas and 2H2 gas. When you're decomposing CH3OH gas into CO gas and 2H2 gas. Now listen, a positive energy should be supplied, right? Which means I have to supply heat to convert CH3OH liquid into what? CH3OH gas. I have to give energy. Then suppose I give amount of X, then can you understand to convert CH3OH gas into what? CO gas and 2H2 gas, I should give what? 128 minus X, because Hess's law. The sum of enthalpies in this direction should be equal to what? Sum of enthalpies in that direction. That means 128 should be equal to what? X plus 128 minus X. X plus 128 minus X is 120. So enthalpies are equal in both directions, right? So yeah, the answer is correct then. The heat absorbed when 1 mole of CH3OH gas is decomposed is less than 120 kilojoules, right? Second one, enthalpy of CO gas plus 2H2 is higher than the enthalpy of CH3OH liquid. Correct. Here we have the products, here we have the reactants. In endothermic reactions, the products have what? Higher enthalpy than what? Reactants. Then here we have reactants, here we have what? Products, and I have to climb what? 128 kilojoules, right? That's the correct statement. Third one, 120 kilojoules of heat is released when 1 mole of CO gas is formed. What do you say? When 1 mole of CO gas is formed, heat is not released, no? It is absorbed. It's an endothermic reaction. Therefore, the third statement is wrong. Fourth one, 120 kilojoules of heat is absorbed during the decomposition of a mole of reactant. Yeah, when I decompose 1 mole of CH3OH liquid, what happens? When I decompose 1 mole of CH3OH liquid, what happens? 120 kilojoules of heat is what? Absorbed. It's an endothermic reaction. Right. Fifth one, 120 kilojoules of heat is absorbed when 32 grams of products are formed. Yeah. Calculate the molecular weight of CO gas and what? Calculate the molecular weight of hydrogen. What do you get? You get 32, right? 12 plus 16 plus 4. You get 32, right? Then what do you get? 32 grams. That clear? Right. How do you get 32 grams? Now, carbon is 12, oxygen is what? 16, right? Carbon is 12, oxygen is 16, you get 28 grams per mole. Hydrogen is what? Yeah, 2 grams per mole. But I have what? 2 moles of hydrogen. That clear? I have 2 moles of hydrogen. Then 28 times 1. 28 grams per mole times 1 mole of CO gives you what? 28 grams. Plus what? 2 grams per mole of H2. But I have 2 moles. Molecular weight times moles gives you the mass. Right? 2 times what? 2. So I get what? 32 grams. That clear? Right, that's understood. Okay, question number 22 now. Identify the incorrect statement from the following. Electron gain energy of nitrogen is positive. What do you say? Just think about the electronic configuration of nitrogen. Does it like to accept electrons? Let's see, right? Now look at this. Electron gain energy, nitrogen. Now nitrogen means what? 1s2, 2s2, 2p3. So 2p3, half filled configuration, no? Electronic configuration is half filled like this. So it's stable. This half filled, therefore what? Stable. If nitrogen accepts an electron, it becomes unstable. If nitrogen accepts an electron, it becomes what? Unstable. Therefore, now listen, it's like this. Now I have kind of a ball like this, right? If nitrogen is in the stable state now, when the potential energy of a system is low, we say that the system is stable, right? Think in terms of physics, right? So if you think about this ball, when it is at a lower potential energy, right, it's stable. So I'm asking this ball to climb to this level, which means what? I should supply what? Energy. I should increase its potential energy. So I should do work. I should supply positive energy. Therefore, the electron gain energy of nitrogen is what? Positive. Chlorine, what happens? Chlorine was unstable, right? Because chlorine likes to become argon's electronic configuration, no? To be more stable. It likes to get noble gas electronic configuration. Therefore, it likes to what? Get the electron. Then chlorine goes from this level to what? This level. Then heat is released. That's why electron gain enthalpy of what? Chlorine is what? Negative. Clear? So nitrogen accepts an electron and becomes a minus gas, right? So there, the enthalpy change is what I'm talking about. The electron gain energy is what? Positive. Electron gain energy is positive, right? Look at the second statement. Dilution of BiCl3 aqueous solution with water gives a white precipitate. What do you say? BiCl3 aqueous reacts with what? Water, liquid, and becomes what? BiOCl, right? It becomes what? BiOCl plus what? 2HCl. This is solid. This is aqueous. So this is the precipitate that's formed. Right? BiOCl solid and what? 2HCl. So this is the precipitate that's formed. Now when I'm diluting this, what's happening to this equilibrium? When I'm diluting this, when I'm increasing the amount of water, the equilibrium shifts to the right, and then what? The precipitate BiOCl is formed, right? So that statement is correct. Dilution of BiCl3 aqueous solution with water gives what? A white precipitate, right? Okay. Third statement. H2S gas can act both as an oxidizing agent and a reducing agent. What do you say? Look at this. Okay, we can see the third statement. H2S gas can act both as an oxidizing agent and reducing agent. Why is this possible? Look at this. H2S gas acting as a reducing agent. Cl2 plus H2S gives you what? 2HCl plus sulfur. H2S acting as an oxidizing agent. 2 sodium plus H2S gives you Na2S, H2. Why is this possible? Now let's see. Look at the structure of H2S. Look at the structure of H2S. Sulfur, hydrogen, hydrogen, like this. Oxidation number of sulfur here is what? -2. Hydrogen is what? +1. This hydrogen is what? +1. Hydrogen can become what? 0. Sulfur can become what? 0. When +1 becomes 0, this is what? Reduction. Right? Reduction. When -2 becomes 0, it's what? Oxidation. H2S oxidizes itself. Then the other reagent, right, reduces. When H2S oxidizes, the other reagent reduces. When H2S reduces itself, the other agent what? Oxidizes itself. Is that clear? Look at this example. H2S acting as a reducing agent. It's going to reduce others, no? Cl2. Now what's the oxidation number of chlorine here? 0. It becomes what? -1 here. In the process, H2S oxidized, no? Because sulfur, which is in -2, has become what? 0. This is an oxidation. Is that clear? But Cl2 is what? Reduced. Therefore, it's a reducing agent. Is that clear? H2S acting as an oxidizing agent. Sodium has become what? 0 to what? +1 times 2 here. There are 2 sodium atoms, right? So sodium has oxidized itself. Is that clear? But the hydrogen here, which was at +1, there are 2, +1 times 2 becomes what? 0. Right? So then here H2S is reduced, but sodium is what? Oxidized. Clear? Right. You can understand this. Now look at the third statement. That's the third statement, right? So that's the correct statement. Okay, fourth one. The effective nuclear charge Z plus Z star fell by a valence electron in helium is less than 2. Now actually if we talk about lithium, it's a different story, right? Let's consider lithium. I'll explain why I'm considering lithium first. We have the nucleus, first energy level, and then lithium. Talking about lithium. Lithium has 3 electrons, right? This is a nucleus. Right. This electron feels the shielding effect. No? Clear? Because of the shielding effect, this electron is repulsed. Because there are electrons in the inner energy level. In the inner energy level, there are electrons. These electrons are going to repulse this outer electron. But this outer electron that's repulsed is also attracted to what? Nucleus. So I'll show the attraction to the nucleus as F nucleus. This repulsion is what? F electron. The electrons in the inner shell, they repulse this outer electron, while the outer electron is attracted to what? The positively charged nucleus. Then resultant attraction is something like Fn minus Fe, right? Some kind of resultant attraction. Therefore, this is not equal to what? Total pure attraction of the nucleus. No? Is that clear? So then, if you think of the nucleus to be having what? Positive charge of +3, what can you say? Yeah, if the positive charge is +3, what can you say? The attraction should be +3 for the electron if the shielding effect is not there, right? But actually what's there? The shielding effect is there. So 3 minus something, no? 3 minus x is the attraction to the nucleus. So this out electron doesn't feel there's a charge of +3. The out electron feels that there's a charge less than 3. Is that clear? Right. But now according to your A-level knowledge, for a question, right, we can think it has what? A wrong statement too. Because we can't easily think about what? A shielding effect, right? Because these two electrons are in this energy level, there are no energy levels inside. So that means there are no electrons inside. Only the proton nucleus is there. The proton neutron nucleus is there. So this positively charged nucleus is exerting an attraction on the electron. So there, as the shielding effect is not there, we can consider the first statement as wrong because the effective nuclear charge felt by a valence electron in helium is less than 2. So you can think of it being equal to what? 2, because according to your knowledge, you'll think about what? The shielding effect. Here there's no such shielding effect. Right, fourth one is wrong. Fifth one. Aluminium is inert towards nitrogen gas even when heated to a high temperature. No, at higher temperatures, nitrogen is not inert. Right? So it reacts with what? Aluminium. Yeah, so the fifth statement is also what? Wrong. So 4 and 5 are answers. 23rd question. The concentration of a dilute aqueous solution of a weak acid HA is C mole per decimeter cube. And its acid dissociation constant is Ka at 298 Kelvin. Which of the following expressions gives the pH of the solution at 298 Kelvin? Now you know HA aqueous mixed with water, liquid, forms what? H3O plus aqueous and what? A minus aqueous. Right. I can say Ka is equal to what? H3O plus aqueous times what? A minus aqueous concentration divided by what? HA aqueous concentration. Now you know that when this breaks down, a certain amount X of what? H2O plus aqueous is formed and a certain amount of what? X of what? A minus aqueous is formed. Because stoichiometry is what? 1:1. X amount of H3O plus and what? X amount of A minus is formed. Then the concentration of what? H3O plus aqueous is equal to what? Concentration of what? A minus. Because it's X and X, right? Right, then I can say Ka is equal to what? K is equal to what? H3O plus aqueous entire thing squared divided by what? HA aqueous. Why I write like this? Now you know HA aqueous means what? Concentration C. They mentioned that. Concentration of HA aqueous weak acid is what? C mole per decimeter cube. So I'm going to write C here. Okay. C. Now I can say Ka times what? C is equal to what? H3O plus aqueous squared. I can multiply by minus log the entire equation. Then I get what? Minus log Ka plus what? Minus log C. Right? Now listen. When you take log of Ka times C, it becomes plus. You know that, right? So what? Minus log Ka plus what? Minus log C is equal to what? Minus 2 log H3O plus aqueous concentration. Now what is minus log Ka? pKa, right, plus minus log C is equal to what? What is minus 2 log H3O plus aqueous? What's that? Yeah, 2POH. Then you get what? I can divide by 2. Then I get what? Half pKa plus what? Minus half log C is equal to what? POH. Half pKa plus minus half log C is equal to POH. Right? pH, I'm sorry, is pH. Log H3O plus means acid, no pH, right? Exactly. So pH is equal to this. Okay, the answer is what? The first one. Right. 24th one. The strength of what? A H2O2 solution can be expressed as what? The volume of O2 produced at standard temperature and pressure. For example, a liter of 20 volume strength H2O2 solution will produce what? 20 liters of oxygen gas at standard temperature and pressure. Right. For example, that, right? That's very important. I'll read again. A liter of 20 volume strength H2O2 solution will produce 20 liters of what? Oxygen. Okay. And 2H2O2 aqueous becomes what? 2H2O liquid and O2 gas. Right. Assume 1 mole of gas has 22.4 liters volume at standard temperature and pressure STP. Right. A bottle labeled X contains H2O2 solution. When 25 centimeter cube of solution X was titrated with 1 mole per decimeter cube KMnO4 in the presence of dilute H2SO4, the volume required to reach the end point was 25 centimeter cube. The volume strength of what? Solution X is. Okay, so we are taking what? 25 centimeter cube of what? X, no? And in the titration, the end point was reached at what? 25 centimeter cube when inserting what? KMnO4, right? What's the concentration? You take MnO4 minus, what's the concentration? They're given the concentration to be what? 1 times 10 minus, 1 mole per decimeter cube. And the volume is what? 25 centimeter cube, right? Now listen. Let's consider the reaction of what? MnO4 minus aqueous with what? H2O2 aqueous. What happens? MnO4 minus plus H2O2. Here we get O2 and what? Mn2 plus. Okay, now see. Oxidation number of manganese here is what? Plus 7. Here is what? Plus 2. So the difference in oxidation numbers is what? 5. Here the oxidation number of oxygen is what? Minus 1 for 1 oxygen. For 2 oxygens, times 2. Minus 1 times 2. You can remember what H2O2 structure is, no? And you can understand. Due to hydrogen is plus 1 here, oxygen is minus 1. Right? Okay. Oxygen, 0. So the difference is what? 2. Then I'm going to multiply this 2 with what? MnO4 minus, and here also what? 2. Difference 5, I have to multiply by what? H2O2. And here 5. Here I have what? 8 oxygens. Here what? 10 oxygens. Then I have what? 18 oxygens here. No? Here I have what? 10 oxygens. I have 10 oxygens and 18 oxygens. Then I should have what here? How many water? Yeah, how much water should I have here on this side? 8 water. No? 8 water should be there. Then I have 16 hydrogens on this side. Here I have what? 10 hydrogens. 10 hydrogens here and what? 16 hydrogens here. Then I should have what? 6H plus here. No need to balance the entire thing for this MCQ, but I just explained for the ones who missed lesson, right? Now listen, we can get relationship now. What is MnO4 minus stoichiometry to what? H2O2. MnO4 minus stoichiometry to H2O2 is what? 2:5. So we understood that. Okay, I'm going to erase this. I'm going to erase this reaction now. We got the stoichiometry, right? So we can say what? MnO4 minus is to H2O2 is what? 2:5, right? Okay. So if I have 1 here, you can divide this by 2, no? I get what? 1:5/2. Right. Now listen, they mentioned this H2O2, 2H2O2 aqueous becomes what? O2 gas and what? 2H2O liquid, right? So what? H2O2 is to O2 is what? 2:1. These things are noted now. See the flow of the question. Now, if I know MnO4 minus moles, right? I can find what? H2O2 moles. Let's see that. MnO4 minus moles. And MnO4 minus is how much? The concentration of MnO4 minus times its volume. The concentration is what? 1 mole per decimeter cube. 1. And the volume is what? 25 times 10 to the minus 3 decimeter cube. So what? Times 25 times what? 10 to the minus 3. Okay. I know NMnO4 minus, right? Then therefore what? H2O2, NH2O2, the H2O2 that was there in 25 centimeter cube. Is that clear? Right. So here is X. So in 25 centimeter cube, the amount of what? H2O2. I can find that. It's going to be what? 5/2 times MnO4 minus, no? Because 1:5/2. Then 5/2 times that. That gives you what? 5/2 times 25 times what? 10 to the power minus 3. I'm not going to simplify now itself. 5/2 times 25 times what? 10 to the power minus 3. Then number of oxygen moles is going to be what? Half of it, no? 2:1 means what? 1:2, right? Then what? Therefore, NO2 is equal to what? 5/2 times 25 times 10 to the minus 3/2. Then what's the volume of what? O2 produced. Yeah, volume of O2 produced. If you consider 25 centimeter cube of what? For 25 centimeter cube of what? H2O2, we can find what? The volume of O2. For 25 centimeter cube of H2O2, I can find what? The volume of O2. Is that clear? Right. I know at standard temperature and pressure, they have mentioned that, right? Yeah. Assume 1 mole of gas has 22.4 liters of volume at standard temperature and pressure. So number of moles is what? 5/2 times 25/2 times 10 to the minus 3 moles of oxygen. If I multiply the moles by what? 22.4 decimeter cube mole per. Clear? Because 1 mole of gas occupies 22.4 decimeter cube. Therefore, 22.4 decimeter cube per mole. If I multiply that by what? This number of moles, which is 5/2 times 25/2 times 10 to the minus 3, I get what? Volume of oxygen for 25 centimeter cube of H2O2. But read the question again. The strength of the H2O2 solution can be expressed as what? The volume of O2 produced at standard temperature and pressure. For example, 1 liter, very important. 1 liter of what? H2O2 of 20 volume strength will produce what? 20 liters of oxygen. At least we have to consider 1 liter of H2O2 when you consider volume strength. Then now here we have seen for what? 25 centimeter cube, the liters of what? Decimeter cube means liters. The liters of what? Oxygen formed. But we want for what? 1 liter. 1 liter means what? 1000 centimeter cube. So I have to multiply this volume by what? 40, because 25 times 40 means what? 1000 centimeter cube. That clear? 1000 centimeter cube means what? 1 liter. For 1 liter of H2O2, then I have to multiply this volume of oxygen by what? 40. Then VO2, right? When you consider 1 liter of what? H2O2 is equal to what? 5 times 25 divided by 4, 2 times 2 is 4, times what? 10 to the minus 3, times what? 22.4, times what? Times what? 40. Then this 4 and this 4 cancels, right? Then 10 to the minus 3, then this 10 becomes 10 to the minus 2. Then I have what? 5 times 25. 5 times 25 is what? 125. 125 times 10 to the minus 2 means what? 125 divided by 100. That means what? 1.25. 1.25 means what? 5 over 4. Then I have what? 5 over 4 times what? 22.4. 5 over 4 times 22.4. Easy. 5 over 4 times what? 22.4. Then I have what? 5.6. 5.6 times 5. Can you do it like this? 5.6 times 5 means what? 5 plus 0.6 times 5. 5 times 5 is what? 25. 5 times 0.6 is what? Okay, you don't know. 5 times 6 is what? 30. Then 5 times 0.6 is what? Do it 1 decimal place back. 3. That clear? So 3 plus what? 25 gives you what? 28. I hope you understood that. So that's the answer, right? So this is going to be what? The volume strength of what? Solution X. Good question. Right. Actually, they have given this for all because they have mentioned normal temperature. I think it's in medium paper, right? Okay, but actually they have mentioned the word assume and things like that. Therefore, you can take the answers 4. Right. 25th question. MOH2 solid is a sparingly water-soluble salt formed by the reaction between M2 plus aqueous and OH minus aqueous ions at 298 Kelvin. Actually, this question is wrong, but let's get some ideas from this question, right? Okay. The solubility of MOH2 solid in water at pH 5 is, so they're asking what? The solubility of what? MOH2 solid in water at pH of 5. And let's see. You know, MOH2 solid, it becomes what? M2 plus aqueous plus what? 2 OH minus aqueous, right? Right. Now listen, they have mentioned the pH is 5, which means it's an acidic solution, right? Which means it's an acidic solution. Now listen, let's consider an instant where we have a dilute solution, right? We have a lot of water, we don't have any acidity, a neutral dilute solution. Then if the solubility of M2 plus aqueous is S, this is going to be what? 2S, because I only have what? MOH2 solid precipitate, MOH2 solid precipitate, and I have what? M2 plus aqueous ions and what? OH minus aqueous ions. That's it, right? If the solubility here is S, this is going to be what? 2S, going to stoichiometry. Then Ksp is equal to what? Yeah, S times what? 2S and I think squared, because Ksp is equal to what? M2 plus aqueous concentration times what? OH minus aqueous concentration into the power 2, right? Actually, that's equal to Ksp. So Ksp is equal to what? Concentration of M2 plus aqueous is what? S. OH minus is what? 2S. So 2S squared. Then I get what? Ksp is equal to 4s to the power 3. Right? We know the Ksp. That's equal to what? 4 times 10 to the minus 36. Right? So this is equal to what? 4 times 10 to the minus 36. Then you get what? S to B on this 4 and 4 cancels. S to the power 3 is equal to what? 10 to the power minus 36. That means what? S is equal to what? 10 to the power minus 36. Yeah, 103 power. Then I get what? Minus 12. So I get what? S is equal to what? 10 to the power minus 12. That means 1 times 10 to the power minus 12 mole per decimeter cube. That is if I have a neutral solution. But now it's acidic. They have mentioned it's acidic. Now listen, if it's acidic, what's going to happen? If it's acidic, what's going to happen? If it is acidic, the H plus reacts with what? OH minus. It's acidic, H plus reacts with what? OH minus. Then the reaction goes towards what? The right, increasing the solubility. Then the answer should be what? A value for solubility which is going to be what? Greater than 1 times 10 to the minus 12. So I should have a value for what? Solubility to be greater than 1 times 10 to the minus 12. Because OH minus, right, reacts with what? H plus. Now you can learn something good from this question. Then when OH minus reacts with H plus, OH minus is reduced. Therefore, the reaction is what? Equilibrium is shifted towards what? The right. When it's shifted towards the right, what happens? The solubility increases. M2 plus aqueous increases. Right? I hope you understood this. So there's no such answer, right? There's no such answer. And also now listen, like if you talk about this, the pH is like what? What's the pH value? pH is what? They're given the pH to be, sorry, yeah, 5, sorry, the pH is 5. So what? H plus concentration is going to be what? H3O plus aqueous concentration is going to be what? 10 to the power minus 5. Actually, H plus concentration is equal to what? 10 to the power minus 5. Then I should have enough OH minus to be able to react to it what? H3O plus aqueous, no? That clear? Got it? So then, can I have such a small concentration react? No. Then again, the question is wrong, right? So this question is erroneous. And also, like if you take, if the pH is 5, POH should be what? If pH is 5, POH should be what? 9. Because pH plus POH should be equal to what? 14, right? At 25 degrees. Then, if the pH is 5, POH should be 9. That means OH minus concentration is equal to what? Now let's see again. Then the OH minus concentration should be equal to what? Then the OH minus concentration should be equal to what? 1 times 10 to the minus 9 mole per decimeter cube. Then I'll substitute here. Now listen, I'll substitute here. You'll see why it's wrong. So they gave all for this question, right? So here 2s represents what? 10 to the power minus 9. 2s represents what? 10 to the power minus 9. So I have what? 10 to the power minus 9 entire thing squared. Solubility is what? S. No? Solubility is S. Here the concentration of OH minus aqueous is what? 10 to the power minus 9 squared. Here I have what? 4 times 10 to the minus 36. Then I have what? 4 times 10 to the power minus what? 18 is equal to what? S solubility. Can I have such a small value? No. I should have a value less than 1 times 10 to the minus 12. Okay, so it's a nice question actually, right? It's a nice question to think, to love chemistry. But actually it's an all question, right? They've given marks for all. You can understand why, right? Question number 26. Which of the following correctly denotes the standard galvanic cell constructed by using the standard hydrogen electrode, the standard magnesium electrode, and a salt bridge at 298 Kelvin? Yeah, to save time I drew the diagram, right? So you can see the magnesium electrode is there and the magnesium 2 plus cation solution is there. H plus solution is there. Concentration 1 mole per decimeter cube. Magnesium 2 plus concentration 1 mole per decimeter cube. This is a platinum rod, and here we have a hydrogen. This is salt bridge. So we can start naming like this. You can follow a path like this, right? You can start from here, go like this, and end up like this. So when you're going through that route, what do you first observe? Magnesium. then magnesium 2 plus. The concentration is what? 1 mole per decimeter cube. And the state is what? Aqueous. Remember in physical chemistry, we are always mentioning the states and the units. Then you meet the salt bridge. When you meet the salt bridge, you mark it like this. Then you meet what? H plus aqueous solution, 1 mole per decimeter cube. Then you meet the hydrogen. Then you meet what? Platinum. So the answer is going to be the first one, right? Okay, now let's look at question number 27. Okay, look at question number 27. Not to save time, I just did the question beforehand. Now look at this. The question says the following procedure was carried out at 298 Kelvin to determine the distribution coefficient Kd of a monobasic organic acid between dichloromethane and water. And this is what's happening. I'll explain. So suppose that monobasic weak acid is HA, just suppose, right? So now I have this HA dissolved in what? The aqueous solution first. I'm taking all the HA and what? Dissolving in what? The aqueous solution. Now I have what? 50 centimeter cube of what? The aqueous solution, right? I have 50 centimeter cube of the aqueous solution. And the concentration is what? 0.2 m for HA. Now I can find the initial amount of what? HA in that aqueous solution before mixing. Now what you're going to do is you're going to take the aqueous layer and this dichloromethane layer and you're going to mix. So before mixing, the amount of HA in what? The aqueous layer can be calculated like this. Concentration times what? Volume. So you get 0.2 times 10 to the minus 3 times 50. Why do you get 10.3 minus 10 to the minus 3 times 50? Because you have to get the volume in what? Decimeter cube. Because the concentration is given in what? Mole per decimeter cube. Then decimeter cube and decimeter cube per cancels, right? So easy things. So you get what? The number of moles of HA initially to be what? 10 times 10 to the minus 3 moles. Then that means what? I have 10 to the minus 2 moles initially of what? HA. NHA initially, right? Then what we are going to do is you're going to mix what? Vigorously. Mixing vigorously. So we are going to mix it what? Dichloromethane. How much do we have? 10 centimeter cube. Exactly. Right. So what happens here is what? Suppose I have the aqueous layer on top and then dichloromethane layer here. Right. So there's going to be an equilibrium. What kind of an equilibrium? HA in equilibrium with what? HA in dichloromethane in equilibrium with what? HA with what? In the aqueous layer, right? So there's an equilibrium. So Kd is equal to what? HA in dimethyl layer divided by what? HA in the aqueous layer. Now sodium hydroxide reacts with what? HA in 1:1 ratio. Because this is monobasic acid, no? Monobasic acid, they react in what? 1:1 ratio. Produces what? NaA and what? Water. Then the number of moles of sodium hydroxide reacted is equal to what? Number of moles of HA that is present in what? The aqueous layer. Finally. Now listen, we are going to mix this up vigorously and then what are they telling in the question? Read the question really well, right? Before the discussion. They're mixing this up really well. And then finally, you have a certain amount of what? HA remaining, no? A certain amount of what? HA remaining. That amount of HA remaining is reacted with what? The amount of HA remaining in the aqueous layer. Now after vigorously mixing, the amount of HA remaining in the aqueous layer is reacted with what? Is reacted with what? Sodium hydroxide. Is that clear? Then if you know the number of moles of sodium hydroxide used to react, then we can find out what? The number of moles of what? HA remaining in what? The aqueous solution finally after mixing vigorously. Is that clear? Right, I hope you understood that. Now listen before that. Now initially the number of HA moles was what? 10 to the minus 2 moles in what? The aqueous layer. Now after mixing, a certain amount of X moles, no? A certain amount of X moles is going to reduce from what? The aqueous layer of HA. And then that amount of X is going down to what? The dichloromethane layer. Is that clear? Right. Then initially I had 10 to the minus 2 moles. Now I have what? 10 to the minus 2 minus X moles. And then X moles comes what? Down to the dichloromethane layer. Right? Now number of sodium hydroxide moles, how can you calculate that? The concentration of sodium hydroxide times what? The volume of sodium hydroxide used. Then you get 0.02 times what? 10 times 10 to the minus 3 moles. Then you get what? Finally 0.02 times 10 to the minus 2 moles. So this is going to be what? 0.02 times 10 minus 2 moles is going to be what? Number of HA moles remaining in what? The aqueous layer. Clear? Number of HA moles remaining in the aqueous layer is going to be what? 0.02 times 10 minus 2 moles, right? Okay, now you know this is what? The number of moles of HA remaining in the aqueous layer. We saw that earlier. No? Initial amount minus the amount that left. 10 minus 2 minus x. Then 10 minus 2 minus x is represented here. That should be equal to what? The same answer. 0.02 times 10 minus 2, which is also what? The HA remaining in the aqueous layer, which we calculated by using what? Sodium hydroxide moles. Right. So that's also mentioned, right? Then we get x to be equal to what? 0.98 times what? 10 per minus 2 moles, right? Then Kd is equal to what? HA in the dimethyl layer divided by what? HA in the aqueous layer. Then you get what? 0.98 times 10 minus 2. The number of moles in the HA layer, I'm sorry, the number of moles in what? The aqueous layer. Number of HA moles in the aqueous layer. Number of HA moles in the aqueous layer divided by what? The volume of what? The aqueous layer. No? To get the concentration of HA in what? The aqueous layer. Is that clear? Now listen. But here we are getting Kd like this. Kd is equal to what? HA in the dimethyl layer divided by what? HA in the aqueous layer. So I had to first what? Find the concentration of what? HA in the dimethyl layer. What's the concentration of HA in the dimethyl layer? Yeah, number of moles of HA in the dimethyl layer divided by the volume of the dimethyl layer. So what's the number of moles? X. That's equal to what? 0.98 times 10 minus 2 divided by what? The volume of the dimethyl layer? 10. Right? So if you multiply that by 10, you get in what? 10 to the power 3, you get in what? Mole per decimeter cube. You don't actually have to multiply by 10 to the power 3 because even if you put in mole per centimeter cube, up and down, right? Centimeter cube and centimeter cube cancels off, right? So it doesn't matter. But if you put in mole per decimeter cube, you have to get what? 0.98 times 10 minus 2 divided by 10 times 10 to the power 3 to get in what? Mole per decimeter cube. And divided by the concentration of HA aqueous. So we get what? The number of HA moles in the aqueous layer remaining is what? We found that 0.02 times 10 minus 2 divided by the volume times 10 power 3. Then you get 0.98 divided by what? 0.02 times what? 5. Then you get 98 over 2 times 5. Then you get 245. Is that clear? Right. That's it. That's the answer. 245, the fifth answer. Okay, look at the 28th question now. Right? Look at question number 28. You can see the reaction. C2H4 gas plus 3O2 gas becoming what? 2CO2 gas plus what? 2 water gas. Stoichiometry between C2H4 and oxygen is what? 1:3. CO2 and water is what? 1:1. I can write 2:2. Same thing. Right? Stoichiometry between C2H4 and CO2 is what? 1:2. Right? Look at this. Rate of consumption of what? C2H4 gas. What's the rate of consumption of C2H4 gas? X mole per decimeter cube per second, right? In 1 second, X moles is consumed when you consider 1 decimeter cube, right? The stoichiometry between C2H4 gas and oxygen is going to be what? 1:3. Therefore, oxygen is consumed at what? A rate thrice this, no? So it's going to be what? 3x mole per decimeter cube per second, right? It's going to be 3 times that. The stoichiometry is 1:3. Then what's the rate of formation of CO2 gas? It's going to be what? 2 times the rate of consumption of what? C2H4 gas. Is that clear? Because stoichiometry is 1:2. Then what's the rate of consumption of C2H4 gas? X mole per decimeter cube. Therefore, what's the rate of formation of CO2 gas? 2 times that. It's going to be 2x. What's the rate of formation of H2O gas? It's going to be what? 2x. So the answer is going to be what? 3x for the rate of consumption of O2 gas. Rate of formation of CO2 gas is going to be what, 2x. Rate of formation of H2O gas is going to be what, 2x, right? In what, mole per decimeter cube per second, right? So the answer is going to be the fifth one. Okay, now let's look at question number 29. Consider the following reaction occurring in rigid closed container at temperature T. M plus Q, all are gases, produces what? R plus Z. The rate of reaction doubled when the concentration of M was doubled. Very important. Rate of the reaction was doubled when the concentration of M was doubled. What's the meaning of this? From this we can understand rate is proportional to what? Concentration of what? M. That means the order with respect to M should be 1. Then M to the power 1. Then only the reaction's rate can be proportional to what? Concentration of M. So the order with respect to M is what? 1. A very important formulation, right? The rate of reaction doubled when the concentration of M was doubled. The rate of reaction is 5 times 10 to the power minus 4 mole per decimeter cube. Right, so we know the rate to be what? 5 times 10 to the power minus 4 mole per decimeter cube per second, right? When the concentrations of M and Q are 1 times 10 to the power minus 5 mole per decimeter cube and 2 mole per decimeter cube respectively. The rate constant of the reaction under these conditions is, right? Now listen, you know the rate is equal to what? Now let's look at this equation first. M gas plus what? Q gas produces what? R gas plus what? Z gas, right? Now I can write the rate like this. Rate is equal to what? Rate constant K times what? M gas into its order X times what? Q gas into its order what? Y. Is that clear? Alright. Now we know X is equal to what? 1, because order with respect to M is what? 1. We understood that because rate is doubled when the concentration of M is doubled. Therefore, the order with respect to M is 1. Then we can say rate is equal to what? K M gas to the power 1. I'm not writing 1 there. Q gas into its order Y. But we don't have to consider its order Y. Now, why is that? Now the concentration of what? Q is much greater than the concentration of what? M. You can see 2 mole per decimeter cube is what? Much greater than what? 1 times 10 to the power minus 5 mole per decimeter cube. That means we can assume that the change in concentration of Q is negligible. So we don't have to think about the changing concentration of Q. Then we can think of this term as a constant. So this is like what? A constant. This is a constant. Then this rate constant K and this together I can represent with a common constant K dash. So then rate is equal to what? R is equal to what? K dash times what? M gas. Right. Now see. Now what's the rate? They're given us the rate. 5 times what? 10 to the power minus 4 mole per decimeter cube. Right? That should be equal to what? K dash times what? What's the concentration of M gas? 1 times 10 to the power minus 5 mole per decimeter cube. H2 rate should be what? Per second, right? Per second. 5 times 10 to the minus 4 mole per decimeter cube per second. Then time that's equal to what? K dash times 1 times 10 to the minus 5 mole per decimeter cube, right? So then when you simplify, you get what? Yeah, this cancels, then you get 10 to the minus 1 here, then 50. 50 what? Per second, right? It's going to be what? K dash. So the answer is going to be what? The fourth one. Is that clear? The answer is going to be the fourth one. Right, look at the 30th question now. Consider the following reaction scheme, right? So we can see, let's look at this. So they're asking P and Q respectively could be, now they're putting Cl2, LCl3, right? Let's see, and they're putting lithium aluminum hydride too, right? Okay. Okay, so I have this carboxyl group attached here, and I'm putting what? Cl2, LCl3. So I'm producing P, right? This is P. And then to that I'm going to put what? lithium aluminium hydride, and then what? Second one, H plus 4, right? This is what's going to happen. Now we have the carboxylic group attached here. This is going to be what? Meta directing. That clear? So these are the ortho, ortho, para, meta, meta, right? These are meta groups, meta positions. These are meta positions. This is the para position here, meta positions here, ortho positions here. So then Cl2 is going to be taken to what? The meta position, right? So I can say the chlorine goes here to the meta position, right? Okay. Now lithium aluminium hydride, H plus and what? Lithium aluminium hydride doesn't have anything to do with the chlorine, right? So what it does is, what, interacting with the carboxylic group, then what happens? You form what? CH2OH, and then what? Cl, right? CH2OH and Cl. So the answer is going to be what? The second one, right? You form this and then you form this. Answer is the second one for question number 30, right? Okay.